Welcome to Tech Lab by Sid. What is a data structure? A data structure is a way of organizing and storing data so that it can be accessed and modified efficiently. The choice of data structure can greatly affect the performance of a program, particularly in terms of the time it takes to execute operations like searching, inserting, updating, and deleting data. In other words, data structures are the building blocks for organizing and managing data in a way that allows for optimized operations. Key types of data structures. There are two primary categories of data structures. Linear data structures. In linear data structures, elements are arranged sequentially, and each element has a unique predecessor and successor, except for the first and last elements. Operations on linear data structures typically involve accessing elements in a straightforward, ordered fashion. Array, a collection of elements stored at contiguous memory locations. Elements are accessed using an index. Linked list, a sequence of elements where each element, node, points to the next. It allows for dynamic memory allocation and can grow and shrink in size. Stack, a collection of elements that follows the last in, first out, LIFO principle. The last element added is the first to be removed. Queue, a collection of elements that follows the first in, first out, FIFO principle. The first element added is the first to be removed. Nonlinear data structures. Nonlinear data structures organize elements in a more complex way, where each element can have multiple relationships with other elements. These structures are often used for more complex relationships, like hierarchies or graphs. Tree, a hierarchical structure where each element, node, has a value and a set of child nodes. The most common type of tree is a binary tree, where each node has at most two children. Graph, a collection of nodes, vertices, and edges, connections between nodes. Graphs can be either directed or undirected, and can represent complex relationships in real-world problems. Operations on data structures. Different data structures allow different types of operations, but common operations include insertion, adding an element to the data structure. Deletion, removing an element from the data structure. Search, finding an element in the data structure. Traversal, visiting each element in the data structure, often used for displaying the elements or performing a computation on each element. Why are data structures important? Efficiency. The choice of data structure can significantly impact the time and space complexity of algorithms. For example, searching for an element in an unordered array takes O(n) time, but searching in a balanced binary search tree takes O(log(n) time. Organization. Data structures help organize data in a way that makes it easier to process and manipulate. For instance, a graph is useful for representing networks, while a heap is useful for implementing priority queues. Problem solving. Different data structures are suited to solving different kinds of problems. For example, a stack is ideal for problems that require reversing elements, like a string reversal, while a queue is better for scheduling tasks in order. Common data structure are arrays, storing fixed-size collections of elements, like a list of student IDs or temperature readings for a week. Linked lists, implementing dynamic data structures like the list of active users on a website. Stacks, reversing strings, undo operations in text editors, or managing function calls in recursion. Queues, task scheduling, print job management, or data streaming. Trees, representing hierarchical data like file systems, or decision-making processes like decision trees. Graphs, modeling relationships such as social networks, web pages, or transportation systems. Summary. A data structure is essentially a specialized format for organizing, processing, and storing data. Different types of data structures, linear and nonlinear, are suited to different tasks, and the choice of structure can affect both the efficiency and clarity of the solution to a given problem. Thanks for watching video.